You know, for over 4 years, we've had a focus in our business that has driven an opportunity for individuals in science to learn about flow. This focus has been around how we use a flow cytometer, how we standardize it, how we learn to build panels to make discovery. Now, 4 years ago, we started because of an early acquisition, and we needed to teach the rules of how to use the new dyes and how they integrate into science. We took that first year and we listened to individuals give us feedback, and they asked us questions about whether or not the technologies and the approaches we were giving could be transferred into different ways to do flow, to examine intracellular proteins. After the second year, we listened again, and they gave us more feedback and asked us whether or not we could transition our technologies and our approaches into the field of cell sorting, for which we did. And this year we did something very special. This year we combined the sorting applications in the field of flow cytometry, and we combined them with next-gen sequencing. And what does that mean? That means that today we can take the technologies we have to find that single cell, to find the one cell that has an impact in biology, and to isolate it, and to take that information that comes from next-gen sequencing and apply that to a bigger question. At the end of the Horizon Tour this year, we're going to show something very special. Data that has been generated off the highest dimensional flow cytometry ever made, that uses all the principles of flow cytometry, that is allow us to be able to look at the single cell at a complexity level that biologists have never been able to do. Because we all know that every biologist in the world needs to know more about a single cell.